Hello everyone and welcome to this Tellit webinar, How to Add Multiple Wireless Technologies to Your IoT Application with Combination Modules and Module Pairing, a live demonstration. I'm Amanda Flink, the Head of Global Events here at Tellit, and I will be moderating today's event. Before we start, we would like to understand what combination of wireless technologies you're looking to deploy in an ongoing project or a planned IoT project. So if our audience could please take a second to fill out our poll question, which you'll see on your screen now. Now let's get to know our speakers. To explain this topic today, I'm pleased to be joined by 4 Tellit speakers. First, we have Chris Cormelis, Regional Product Specialist at Tellit. Second, we have Ken Bednes, VP of Application Engineering. Third, we have Steve Weirs, our Regional Sales Director for the Midwest at Tellit. And lastly, we have Venkata Kiran, a Wi-Fi Field Application Engineer at Tellit. Just before I hand it over to Steve to start the presentation, I do have a few quick reminders for our audience. I would like to encourage you to interact by posting questions. We will have time to answer some of those at the end of this presentation. You can simply submit using the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for some additional information. And finally, we will send out this replay link to all attendees at the conclusion of the webinar. And with that, Steve, I will hand it over to you.
Thank you, Amanda. And greetings to all, and thanks for attending our webinar today. I know your time is valuable, and we hope you find this useful. So let's get started. First, I'll introduce the topic. So both cellular and Wi-Fi are solutions to connect things to the internet. And there's advantages to each one of those, right? I mean, cellular has its unique advantages, Wi-Fi has its unique advantages. But there may be applications or use cases where you want to combine the two connectivity technologies. So that's the goal of this webinar. So we'll describe these use cases. I'll go through where multi-radio connectivity may be required. And in doing that, there's a certification aspect that we'll discuss. And then we'll talk about component examples that enable efficient implementation, and then we'll actually demonstrate an actual solution. So I hope you enjoy the show here, and let's get into it. So use cases, I've got 4 different groups of examples. The first one would be BLE or Wi-Fi to cellular gateway. And where this would come into play, so say you have a local network of BLE or Wi-Fi enabled devices, and you want to get data to and from those through a cellular gateway to a remote host. So you'd have this gateway in there, and the solution would be a device has cellular uplink to a network, and then a local wireless connection that can serve as an access point or a BLE central device that can talk with or interface with local networks of these devices. The second would be dual mode network connectivity. So let's say you have a cellular enabled device and you want to communicate up to the network. There may be instances where, I don't want to use cellular, maybe it's not available, maybe you have large payloads to send and you don't want to absorb the cost of the cellular connectivity in those instances. Or maybe you just want a failover transfer methodology. What we'll show is you can have both cellular and Wi-Fi in a low-cost device, and under application control, you can select which backhaul you want to use for a particular operation. The third would be cellular connectivity with local BLE access. So it's pretty common to have cellular connected endpoints, but there might be a use case where you might have a mobile device that approaches the node and wants to connect to it either to transfer data, to update firmware, or things like that. So you'd have a application where you've got cellular module for backhaul, but you want also to provide a BLE connection that a mobile device can connect to it. And then the fourth would be asset tracking. You know, there's a plethora of asset tracking solutions out there where you have a GPS receiver or a GNSS receiver, and it's taking fixes or locations on a periodic basis, sending them up over the cellular network to a remote portal. And that works well for outdoor applications or applications, where you have the antenna with a view of the sky. But for indoor tracking, the GNSS receiver might not work so well. So you can augment the GNSS receiver tracking with some type of indoor positioning. Could be Wi-Fi triangulation methods or BLE using beacons. But it's possible, and we have customers doing this, where they'll augment their GNSS receiver location capability with some indoor tracking capability. Now I'll go to the next slide. I'll show you a little bit different view, kind of a block diagram format of what these two configurations would look like. So in the first configuration, we've got cellular module, and in that module is running an application in what Tellit would call IoT app zone, and its primary connection to the cloud. So in a couple of the use cases, you might want to provide for an alternate connection, and that could be through the Wi-Fi module. So the cellular module would use the Wi-Fi module as a peripheral and connect to the cloud through a station connection provided by an access point. You also have the option in this configuration to transfer data to and from a mobile device. In the second configuration, you're using the Wi-Fi BLE module purely as a peripheral. So you've got the cellular module with its uplink to the cloud, and then this Wi-Fi BLE module is serving up either an access point or a BLE central connection, and you can network local collections of devices. They could be Wi-Fi enabled devices, they could be Bluetooth enabled devices. So it offers a lot of flexibility in the case where you have a number of different nodes. It could be hundreds of nodes, and you want to route that data through a cellular connection up to the cloud. So I hope that gives you a picture of the types of things that we're doing, and the kinds of use cases that we're seeing in the marketplace. But now the issue, of course, with this kind of architecture is you have two radios in the product. And keep in mind, Tellit, most modules on the market have FCC modular approval as an individual device. Well, when you combine these two modules together, things can get a little bit more complicated. So it's the coexistence problem. And with that said, I'm going to introduce our next speaker, Ken Bednadz, and he'll go through the issues that you need to think about and solutions for coexistence of multiple radios. So Ken, take it away.
Thank you, Steve. Thanks for the great introduction. My name is Ken Bednadz. I'm responsible for our application engineering team here at Tellit. And so what my team does is work with our partners and integrators to try to help work with you to select the right technologies, the right architecture, and then help bring your products to market. So we will help with any design reviews, technical questions, and certification questions. So our goal is to get you to market as soon as possible. And what we're going to do today is talk more about coexistence, what it is, how it can impact your design, and how to avoid it. So today we see devices are getting more and more innovative. We see many IoT devices including multiple wireless technologies inside. We see a lot of IoT devices that may include cellular, whether it's 3G, 4G, 5G, cellular technologies. They could include some of the 2.4 gigahertz technologies like Wi-Fi, Bluetooth, could include other proprietary technologies at 433 or 900 megahertz, could include, endpoint technologies like Z-Wave, Zigbee, or others. And so we are seeing innovative devices hitting the market that include multiple technologies in one single device. And like Steve was mentioning, this could be done for a variety of reasons. One could be availability. They may want two different wireless technologies depending on where they are and what's available at the time. They could require multiple technology for fallback. So it may start off with Wi-Fi as being the lowest cost routing option, but as they move outside of that Wi-Fi access point, fall back to another technology like cellular technology. We see others that are using a secondary wireless technology just for configuration, what they call like a headless configuration. So we see a lot of these sensors, they don't have a display or interface on them, but you can maybe use your cell phone or other device that has a display to help configure that device. We're also seeing multiple technologies used for gateways, right? So as Steve was mentioning, to pull out the data. So you may have endpoints that are communicating on a more local area technology, whether it's Wi-Fi, Z-Wave, Zigbee, proprietary, and then pulling that data into a gateway and then spitting it out over cellular or Wi-Fi over to the internet. So we are seeing a tremendous amount of unique use cases using multiple technologies. And so what does this mean for us? What does this mean for the integrator, and how do we get you to the market successfully to make sure you can keep your deployment schedules and timelines? Well, we have to understand, what coexistence is. And when we talk about coexistence, we're trying to talk about it from a regulatory perspective, okay? And the way they define coexistence is when you have two or more wireless technologies transmitting at the same time. So just because your device may contain multiple wireless technologies does not mean that you have coexistence in terms of what the regulatory industry defines coexistence as. In order to have coexistence, you've got to be transmitting at the same time. And it's very important for us to understand. And so when we have these very generic or general devices, like a cellular phone, for example, it absolutely has coexistence because you have Bluetooth, Wi-Fi, cellular, and other wireless technologies that can be turned on and off at any given time. And so that type of device definitely has coexistence and needs to go through some additional certification testing and additional design requirements that we'll talk about a little bit later. For IoT, a lot of the use cases are more specific and can really avoid coexistence, right? And so sometimes you may need multiple technologies, but you're only going to use one at a time. And so we'll cover that aspect too. But again, some IoT devices may not be able to avoid coexistence. So the whole idea here is really making sure that you understand what coexistence is and how it can impact your design. Here we have six items that can be impacted if your device requires coexistence support, right? And it could be anything from the product design. And when I say the product design, I'm talking about the mechanical idea of the product, the shape and size of it, RF design and board layout. You really have to understand what you're designing for. If you're designing for one wireless technology to work at one time or both, because if they're both going to work, you have to worry about filtering and how you reduce noise and interference. A perfect example of this is cell phones. If you take apart a cell phone today, you will see a lot of shield cans. You'll see those metal cans covering these different wireless technologies and kind of isolating the RF interference, the cross-pollination noise. And so those shield cans are not there to make the phone look pretty by any means. They're really there to serve a very important purpose, and that's to optimize performance for coexistence. Other impacts is obviously antenna design, antenna separation. When you have multiple technologies transmitting at the same time, you want a really good antenna system, but you don't want it to be too broad or too wide because it could pick up noise from other technologies and other frequencies that you're not planning on. Firmware development strategies. Even if you have coexistence, you may want to try to minimize it, right? But when it comes down to with coexistence, we at Tellit, we can help you through all these different aspects of it. the most challenging part of it really comes down to performance and making sure that you are going to get the range, RF sensitivity, and the performance of your device when you're transmitting multiple technologies at the same time. That's the biggest challenge that we see in the marketplace today. Steve was also mentioning about the regulatory approvals. We're going to touch on that very quickly, about what it takes to bring a product to market without coexistence and with coexistence. And that's an area that is fairly manageable if you follow a couple aspects that we'll mention here. Okay, so best practices. So one of the things we want to mention today, and Steve touched on this, about using a pre-certified module, whether it's, no matter what wireless module, if it's Bluetooth, Wi-Fi, Cellular, Zigbee, Z-Wave, whatever it is, if it already has FCC approval, the regulatory approvals, the ISED or the IC approval for Canada, is one thing. And then you need to make sure that it has modular regulatory approval. And what modular approval means is that you can reuse the test results, you can reuse all the work that the module provider already did with the regulatory bodies. And that really streamlines the process for your device, whether you're using coexistence or not. And so I think that's one of the best ways to help reduce risk and ensure you launch a product successfully, is making sure that you use a pre-certified module, wireless module, with modular regulatory approval. And we can talk a little bit more about that as we get a little bit deeper into the presentation. And then obviously the design, right? Before starting your design, we have to understand, are we going to fight the coexistence challenges or are we not? And so again, this will impact everything from your design strategy, from antenna, RF, software, and certification. When it comes to how do we mitigate the risk of coexistence, is to really eliminate coexistence, right? So if you can define a use case that's scalable, that'll meet your requirements without having to transmit multiple wireless technology at the same time, it really helps eliminate a lot of risk, right? It eliminates a lot of risk when it comes to RF performance and interference and your RF design. So it's really important here to really determine if coexistence is really required. And as far as designing with coexistence, like I mentioned, what I want to spend a couple of minutes on is the really big risk area, which is RF interference, RF sensitivity and range. And this really comes down to doing your homework, working with Tellit, understanding what wireless technologies you're working with. And what I mean is, different wireless technologies have different output powers. So you may have a 2G radio that transmits 2 watts. 2 watts is a lot of power coming out of a device. But you may be working with 4G LTE that mainly only transmits at 200 milliwatts, 10 times less. It's much more manageable when it comes to the RF noise and RF interference that's going to cause in other technologies. So really knowing what you're working with is extremely important. Mapping the frequencies and harmonics, right? Understanding all your clock frequencies, understanding what harmonics of your wireless transmitters could interfere or cause interference with other wireless transmitters, especially in their receive frequency path. And then you can kind of determine what RF filtering options are needed. Do we need to knock down harmonics of some of the wireless transmitters to ensure or reduce interference? Antenna design, right? We don't want the antennas to be maybe too wide, because then we're picking up the cellular antenna is picking up the Wi-Fi is picking up the cellular, or we have the Z-Wave or the Bluetooth or whatever it may be. So really focusing on RF design is extremely important when you have to deal with coexistence. And this is the biggest challenge, is making sure that your design will work well in the marketplace. And when it comes to RF performance with coexistence, this is not going to be tested by the regulatory bodies. This may not be tested by some of the certification groups. This is going to determine how well your product performs in the marketplace. And so this is why, I always deem this as the biggest risk when it comes to coexistent designs. And we'll touch, again, real quickly on certification. And so what I promise is we'll talk both about, one use case where we don't have coexistence, where we have two technologies, 2 wireless technologies. So we could take cellular and Wi-Fi, and they're transmitting not at the same time, so there's no coexistence we have to deal with. That is fairly a straightforward use case when it comes to regulatory approval. As long as the modules you're using have FCC and ISED approval for Canada, you can easily reuse those FCC results, and the only testing you really need to do is FCC Part 15, which is unintentional radiator. So it's a very straightforward process. You're reusing the FCC ID of the module provider. So fairly straightforward, very cost effective. You may only spend, a few $1,000s on FCC approval and ISED approval, and you're good for market, right? So very straightforward. When it comes to coexistence, certification is also very manageable, but there's some additional steps you need to take. As long as the wireless modules have the modular FCC and ISED approval, you can reuse all the test results, all the transmitter test results from your module provider. You will have to do some additional coexistence testing, and this really makes sure that you don't create additional harmonics. This is, I would say, low-risk testing. You will need to do a new filing with FCC and ISED to get a new FCC and new IC Industry Canada IDs. But again, it's a very straightforward process. There's not a lot of risk in this process. The key here, in order to achieve these processes with co-location without, is making sure that the modules you're using have the pre-approvals with modular approval. Okay, so what I'm going to do now is pass over to Chris Cormelis, who's going to highlight the products that we're going to demonstrate later today in the demo.
Yeah, thanks, Ken. As Ken stated, I'm going to be going over some of the products that we'll be reviewing today that's going to be placed in the demo. Again, I'm Christopher Cormelis. I'm the Regional Sales Specialist. My primary focus is our short range and GNSS portfolio. So kind of going over an overview of what Tellit has to offer. So besides cellular and the Wi-Fi modules that we'll be reviewing today, we also offer 5G and positioning. And our modules are great as a standalone themselves or being combined. Kind of the central point of this presentation is doing one or the other and showing the combination of these modules and how they could work well into a true IoT application. The first module I'll be reviewing right here is our cellular module. It's the ME910C1. It's an LTE Cat 1 with an uplink of up to 37 kilobytes per second and a downlink of 300 kilobytes per second. For Cat 1, for narrowband, it's 21 or 62 kilobytes per second. The form factor is 28.2 by 28.2 by 2.2 millimeters. So this is a standard 910 form factor of Tellit. Tellit typically does a standard form factor, so you could have an easy transition if you're going to move to a newer technology or a different technology to incorporate it into your next platform. We have different region sets: North America, EMEA, Korea, Japan, and with that, we also have an array of certification. As Ken stated, we have a lot of regulatory approvals like FCC, RED, etc. So it's listed here on this slide, so you can review it at a later time. And with this module, you also have integrated GNSS. So with that, it comes with GPS, GLONASS, Beidou, Galileo. Depending on your region set, you might require this in those regions, as well as industrial grade temperature. And with this, and I'll kind of review it later, is we have Tellit kind of systems like OneEdge, firmware over the air, SIM-wise. So these are all inherent within this device already, and some of the drivers supported is Windows, Linux, and Android. Some of the applications that we're seeing these devices kind of going into is smart metering, security, point of sale, self monitoring, some fleet management, especially with that embedded GNSS, asset tracking, and wearables. Some of the key benefits are 3GPP, enhanced coverage for better enriched, indoor positioning, ideal migration paths, and we also support 2G fallback in this device, so it's 4G and 2G as well. The W310, so this is what we'll also be combining this device as well. This is a Wi-Fi combo unit, so it supports 2.4 gigahertz as well as Bluetooth 5. So with this device, you could output both simultaneously. So it's an LGA, and we offer two configurations with this device. So one is with an integrated antenna, and one's with an external antenna. The size is slightly different in this package size due to the antenna. So with the integrated antenna, it's 18 by 15, and without it, it's 14.3 by 13.1. And the architecture supported this can be hosted or hostless. It does have an internal flash of 4 megabits. It does support firmware over-the-air upgrade, as well as some of the host interfaces as UART, SPI, STIO. So, for that faster throughput, maybe doing the STIO is something that you want to look into. And just like its counterpart that I showed, it has an array of approvals such as RED, FCC, IC, Wi-Fi Alliance, and Bluetooth SIG. And some of the applications that we're seeing this device going in is thermostats, a lot of more home applications, right? So thermostats, air purifier, air conditioners, security, some pet dispensers. Some of the key benefits here is we do support WPA3 as well as TLS 1.3 and of course TLS 1.2. Optimized power consumption for better battery life for those battery operated devices. So, and then App Zone 5 is going to be supported, so you could build that application space right onto the device. So that's some of the feature sets of the two devices we're going to go into, as well as the data sheets and information is based on our website, so you can kind of dig a little bit deeper if these products do interest you. So kind of the additional product features that we'll be demonstrating is some of the applications that we bring with Tellit. So besides having modules, we do have Tellit SimWise, Tellit One Edge, Tellit Application Zone, and then with that, you could test these out on our evaluation boards. So with the application zone, you could actually run your application code directly inside the Tellit module. So a little bit nicer integration of your device. One Edge, it's software suited integration with development and management of tools. So we kind of provide a lot of your support with these extra features and feature sets that we incorporate within the module and within the Tellit support realm. And the evaluation boards, we bring out a lot of nice feature sets, and Karen's going to go into kind of how the evaluation board works and go into a little bit more of this demonstration based off two of our evaluation boards, based off the two modules that I kind of shortly reviewed, the W310F5 and the ME910. So Karen, if you want to go into your demonstration.
Hello everyone, my name is Kiran. I'm a field application engineer in Tellit. I primarily work with Tellit short range wireless modules. First of all, thank you for joining this webinar. In today's demonstration, I would like to showcase the use cases where multiple wireless technologies are required. So as a consideration, I took two use cases, two requirements where a multiple technology need is arised. So one is when you have reliable and continuous data streaming requirement is there. In such cases, you might need a multi-wireless technology. Let's take an example of mobile cardiac telemetry system, which requires a continuous data streaming. Even one wireless technology goes offline, others should come and use it as a backup. For example, if you are at home, you can use one wireless technology. If you are on the move, you can use another wireless technology. So other requirement we consider is like a high throughput data requirements, where you have a fleet of cars where you continuously collect the video footage when the car is on the move, and you want to upload the data. So if you use a cellular technology to upload the data, your cost will be more. Rather, you can use other wireless technology when the car move to a hub or a service station. Maybe you can use a Wi-Fi technology there, and then you can upload all this streamed data to the cloud. So, but our basically our demonstration primarily focusing on the first use case, where you need a reliable and continuous data streaming. Based on that, we have designed a sample application. I'll in the next slide I'll go and explain that block diagram. So this is the block diagram which we considered one of the use case, where you have a continuous a combo wireless product which is having all the three wireless interfaces. So one is the cellular, and this one is the Wi-Fi and the Bluetooth. We use each wireless interface for its own purposes in this demo. So one is Wi-Fi, which is been used as a default communication path. Whatever the data we have, we want to upload using the Wi-Fi, and we use a BLE interface just to provision this product to connect to a wireless access point. Uh, and the cellular technology can be used as a backup communication path, just to upload the same data over the cellular interface. Now and as a communication path is concerned, we use MQTT protocol. MQTT brokers are available everywhere in our cloud infrastructure. So we took Tellit's device-wise as a cloud infrastructure, and we have our own MQTT broker there, and that will used for communication purposes. So we use MQTT client, another client who can view this the data which has been posted by this combo wireless product, can be viewed or analyzed using a dashboard. We use a freely available an application, MQTT Explorer. So in the next slides, I will explain what are the components are required for running this demo. And as a combo product is concerned, as I said, it have multiple wireless technologies like cellular, Wi-Fi, and Bluetooth. We use two different modules from Tellit. One is a MU910C1, which is a cellular module, CATM module, which is used for a cellular part, and it also acts as a host. So you can write your standalone application that can drive your Wi-Fi, or all the application you can implement on this the host MU910C1 module. So as a simple application, we have implemented this to use a multiple wireless technologies, but the MU910 has a capability to write your own standalone application, or you can use this from an external host to give a AT commands to the MU910. But in this example, we use this as a primarily as a host, and also we use the cellular capability, and we programmed in the module to communicate to a device-wise cloud using MQTT protocol. So the whole stack is reside in this MU910. And W310 is a combo module which is having a Wi-Fi and the Bluetooth combo coexistence. They can run simultaneously at any point of time. And this W310 F5 is a single band module, so it supports 2.4 gigahertz. And this is one of our latest module. And these two modules will communicate over the UART interface, where W310 Fi is having its own application where the host can give AT commands to configure W310 to connect to a wireless access point and then publish your data to the MQTT. That's about the demo application. And coming to the required components to run this demo, these are the prerequisites. One is MU910 board. Basically the module is mounted in our board. This is a new Brevo board. We call it as a Brevo. I have provided a link for each of these components what we have used to get more explore more into the product. So this Brevo board is a simplified evaluation board for a cellular evaluation. And it has its own sensors, like we use a Bosch sensors to basically collect the motion detection, or environmental sensor to collect the temperature, humidity, and pressure. So this information, basically in this demo, we collect this sensor information and then put it to the cloud. So at the same time, in the W310 F5, it's a Wi-Fi module. It's an evaluation board picture, and which eventually take commands from MU910 and then connect to the cloud, and post the same sensor data will be given to the W310, and this will be published to the cloud. And we have for a BLE interface point of view, we use a BLE provisioning, basically for connecting this W310F5 wireless module to your home access point, or a environment, or a enterprise access points. If you are considering about offices and other factories, things like that, the infrastructure will be different than the home environment. In the home environment, we use the Wi-Fi access point with the WPA security, WPA2 security, where in office environment we have enterprise security. So this module is capable enough to connect to both personal as well as the enterprise level security access points. So you can provision a BLE device using this provisioning app. You can provision this Wi-Fi device to connect to an access point. And we use the MQTT Explorer to see what data has been published by these two guys. Either by default, Wi-Fi module itself will publish. When it is on offline, the cellular module will publish. But either ways, you can continuously see the data which is coming from this whole product to the MQTT Explorer app. So these are the different interfaces we have used: Wi-Fi, BLE, cellular, and serial interface. As I already explained, Wi-Fi used for a data path. It's a default data path, and BLE is for configuring the Wi-Fi module, and cellular interface is used for as a backup of Wi-Fi, and serial interface is used for communication between the Wi-Fi and the cellular module, like this interface. Coming to the demonstration, we have a Bravo board. As I said, as soon as it boots up, it comes up and look for a Wi-Fi networks and check the Wi-Fi module is been connected to the Wi-Fi network or not. If it doesn't connect, it thinks that it's the first time provisioning, and then first time boot up, and it put the module into the provisioning mode. And so that a mobile app, which is a smart phone application which is running on iOS, can connect to this Wi-Fi module using a BLE interface, and upload the Wi-Fi credentials of his home network or office network, whatever the Wi-Fi credentials that has been uploaded to this module, and the module will use those credentials and try to connect. And if it successfully connects, it fed back to the provisioning app, so that he's code able to successfully connect to it, and then reboot, and this will go and connect to the network. So once it has been connected, and Bravo bot sees that it is connected to the network, and keeps taking the sensor data periodically for every 5 seconds, and then putting that data into the cloud. So, and also checks that when you can view this data into an MQTT Explorer, that I will demonstrate in a little time. And then in case if the Wi-Fi fall offline, in case of Wi-Fi there is no internet connectivity, or if any case, if the MQTT publish returns an error, or connection establishment returns an error, we eventually fall back and use the cellular network. So that's about the presentation part, but now we'll go and demonstrate the use case. So here I have here we have two terminals here. So one terminal is on my left hand side is a cellular the terminal which is connected to the cellular module or the USB, and on my right hand side it is a serial interface connected to a Wi-Fi module. So just to print the debug messages, we just added some debug prints, so those can be printed over the serial interface. So now let's go ahead and I will restart my board. Now I restarted my cellular module, which is initializing its sensors. And once it get initialized, it start giving commands to the Wi-Fi module. So you can see as and when it sends a command, it's sending a command to it. Here it's waiting for checking whether network connection has been available on the cellular module. Since it is not available, it's just resetting the module to the factory mode as a first time boot, and then saving that into profile and reset the system. So all these commands are coming from this host to the Wi-Fi module. So these are the two commands just for safety purposes we have added. We are make sure that we are disconnecting from the network correctly. Even since it is not connected, it's thrown an error, but it's a safety check. Now you can see the module as not started the Wi-Fi, but it started the Bluetooth interface, Bluetooth initialization, and it set a Bluetooth name, and this name will be visible on your phone, and it started the provisioning mode. Tellit provisioning app available. You can go ahead and start that. This app can run in two ways, either in Bluetooth provisioning mode or Wi-Fi provisioning mode. In this demonstration, I will be showing a Bluetooth interface. So this interface now detected the a Bluetooth device, that is our device W13F5 followed with that MAC address. I can go ahead and connect to it. So as soon as I connect, it scans for the Wi-Fi networks. Basically, it gives instructions to the Wi-Fi module to scan the Wi-Fi networks in your vicinity and give back to me. So okay, now anytime soon you will see a multi-technology network. So I have just started, and in the scan results you can see that it dynamically updates the scan results, and my password was 01. I submit that. As soon as I submit, this information will go to the network, and then he passes it goes and connected to that network. So now you can see the module is successfully connected, and now it is starting the system time. Why? Because we use SSL MQTT over SSL communication, we need a system time to validate the certificates. So we are starting SNTP client in our Wi-Fi module to sync with the network server. So once it is get synced, then it get a time. In the meanwhile, I'll go ahead and start the Explorer. So this is the Explorer which I used for viewing our data. So we have a Tellit device-wise API. Basically, this is a host name where I have configured my device name, and I'm just go ahead and connecting to it. And I also subscribed for a topic which is my device Wi-Fi device name topic. Basically, you can consider this as a product topic. So since that has been saved, and I go ahead and connect to it, so I successfully connected. You can see as my system start publishing this data, so it is publishing the signal strength. So I have captured some of these parameters. So basically, it's a JSON string we are passing continuously, and we try to plot the data using this tool, where V indicates that the signal strength part, and T is a temperature, and H is a humidity, and P is the pressure. So we are taking the pressures, all this pressure sensor information from the Bravo board, and give it to the Wi-Fi module and trying to plot that graph. And here we are taking the Wi-Fi module's own sensor values, not sensor, Wi-Fi module's own signal strength, and trying to plot that. So you can see dynamically, if I I'm placing my hand on the antenna, your RSSI will further falls down. Now you can see it's fall down from 28 to -32, and if I keep it hand like that, and then continuously it further falls down. Yeah, now it goes to 34, and I remove my hand now, and it will come to a proper signal strength. So it came back to 30. So again, this is the different plots we are giving. What I'll do is I'll just go ahead and stop the Wi-Fi network. I'll do it from here. Just a minute. Now I stop the Wi-Fi network, but it got disconnected, and choose a cellular path. Automatically cellular has been initialized and cellular network got connected, and it start publishing the data via cellular interface now. So you can see basically we are sending it from the cellular path. So you can see this has got disconnected, like this is the Wi-Fi got disconnected and it's got closed. So you can see here the data will be published in a periodically in the same 5-second interval, but there is no interruption happens since even the first few iteration it sends using the Wi-Fi, and so Wi-Fi goes offline and then it started sending a cellular data. So maybe in order to differentiate here, initially we plotted a Wi-Fi signal strength, and now we are plotting the cellular signal strength values. So this is what the demonstration. I hope this suffice or satisfies the requirement of continuous data streaming or reliable data streaming using multiple wireless technologies. Thank you.
Thanks, Kieran. Really great demo there. Audience, before we get to our Q&A portion of today, I am going to drop one last poll here on your screen. If you'd like to have one of our experts contact you, please respond here on the poll and someone will reach out directly. We do have time for a few questions now, and there is still time to ask a question, so please go ahead and submit using the box right next to the slide presentation, and we will do our best to cover it. We've gotten a couple questions so far, so I am going to just dive right in here. First question here, did this example demo result in true coexistence, or were cellular and Wi-Fi transmissions controlled or coordinated?
Hey, Amanda, this is Ken. I can jump in and start that, and then Kieran, if there's anything to add, he can add on the end. But basically, this demo did not result in true coexistence. Just like many of the IoT deployments today in devices, they have coordinated control over the different wireless technologies. So in this demo, we focused as Wi-Fi is our primary path, and then when Wi-Fi was not available, we fall back to cellular. So it was not true coexistence, but it did appear, or we did use multiple wireless technologies.
Great, thanks, Ken. Next question we've got. It appears that the WE310 Wi-Fi provisioning can be done over a BLE connection to a mobile device. Can Tellit support the mobile side application development?
Yes, thanks, Amanda. So yeah, we do support. We do have a reference applications in mobile app side. We do have sample applications in Android and iOS as well. And inside the module also we can configure. We have a web server. Using a web server also we can provision this device. We have multiple kind of multiple ways to we can provision the device. So yeah, we have a source code available for the sample applications we can share as part of our SDK.
Great, thanks, Kieran. Next question we have here. Where is GNSS in all of these Tellit modules? For IoT, we need position information as a primary source of data for fleet and remote applications.
Yeah, Amanda, this is Ken. I can jump in on this one too. Let's remember, when it comes to GNSS, we're talking about global navigation satellite systems, and so these are actually receivers only, so they don't count as a transmitter, right? They're only a receiver. And so the modules that we have at Tellit have integrated GNSS support. They support the 4 global constellations, so GPS for the US constellation, GLONASS, for Russia, Beidou, Galileo, and then also we have support for the local Japan system, the QZSS. So all of our ME, Cat-M, narrowband products, our LTE products do include integrated GNSS positioning that is part of the product. We just did not demonstrate that today.
Great, thank you, Ken. And I think this next question may be for you also. How is the design's compliance with FCC ensured given the co-location of multiple modular transmitters? Will retesting be needed?
Right, okay, so in a demonstration today, we did not, it was not true coexistence in terms of regulatory approval. And so for what we demonstrate today, it's very easy where an end device could package up the Tellit Cellular module, the Tellit Wi-Fi Bluetooth module, and they could list those FCC IDs. The Tellit FCC IDs could be reused and listed on the outside of the customer's end device or the partner's end device. The only testing that would be required would be the FCC Part 15 testing, which just costs, $1,000 to $2,000. It's very straightforward for unintentional radiator to make sure when the device is powered up and nothing's transmitting that there's no emissions coming out of the device. So really the demonstration we did today could be packaged up using Tellit FCC IDs and launched for $1,000 to $2,000 in FCC testing.
Thanks, Ken. Next question I have, what cellular technologies does Tellit support for Wi-Fi bundling?
Okay, yeah. So when it comes to the cellular technologies with Wi-Fi bundling, we do support 4G LTE in a couple different flavors. We have our LE910C1 series, which is LTE category 1. And what that means is that we support 5 megabits per second uploads and 10 megabits per second downloads. We also support 4G LTE category 4, which is a much higher bandwidth technology, which is about 10 times the data speeds as Cat 1. So it supports 50 megabits per second upload and 150 megabits per second download. So that would be used in more real-time streaming applications. And then we also support our LTE category M1 in narrowband IoT, which is demonstrated today. And so that's the more entry-level technology with lower data speeds and a clear path to 5G technology support.
Great, thank you so much, Ken. I believe that's all the time we have for today. We're coming up on the top of the hour here. Please be sure to check your inboxes for in the coming days for a replay link. You can go back through and watch this demo again. Thank you, Chris, Ken, Steve, and Kieran for the great information today. And thank you to all who joined us.